A few final remarks for the preparation for the exam. Final remarks. So one thing that I noticed for the first exam is that while you all performed incredibly well in each one of the partial evaluations, namely the quizzes, you didn't perform as well in the same type of problem when they were asked during the exam. So I would recommend to recommendations, go over past quizzes. So those after the first exam, first midterm, that's the first thing. Go over each one of them, and with a focus on learning to recognize what the problem is about, so what section it belongs to, and what you were supposed to do. Okay, so in do the recommended problems of each section. This is something I've been posting recommended problems since the beginning for each section. Go over each one of them. That will be definitely good. Then I would ask you to, it would be really beneficial, I think, to you to work out the problems seen in class. So the idea would be that you will attempt them. You just read the statement of the problem and try to work it out on your own. And after giving it a try, sincere try, then you can just check your work with your notes. And this until you're completely sure that you can. When presented with a problem like that, you can go until the end. Okay, so that's all the 3 general recommendations. Now some recommendations about problems in general. So you should probably keep in mind that you'll see this. This type of problems. There will be problems for sure that ask you to find certain types of problems you likely to find. And this goes back to the first point that I was trying to make, and that is that problems from past quizzes are going to appear again. I remember you missing the sign of 4x over x limit in the first exam, while in the quiz nobody missed even more complicated problems for the same section. Okay, so types of problems you're bound to encounter. Having said that, things are going to be slightly different this time because the exam is not going to follow the same format as in previous years for obvious reasons. We have to transform everything to an online course, and so things are being adjusted until very recently have been underway. So but no matter what, you're gonna be asked to solve problems that test your knowledge on each one of the past sections. It'll be typical problems. I would say that definitely the problems will be like web assigned problems for each section. So I would definitely give it a try to work on problems from web assign. But one type of problem, like find the equation the equation of the tangent line of y e to the x, let's say x e to the y is equal to 4, and at, say, at a certain point, like 4, 0. If you look at your notes, you'll see how to tackle this problem. This is actually part of the implicit differentiation section. So y here is a function of x, is defined implicitly. So what you do is just differentiate everything on both sides, keeping in mind that here, since you're differentiating with respect to x, e y prime is the e to the y with respect to x. So you need to apply the chain rule to get e to the y prime. So don't forget that, otherwise you're not going to get the result. This is the only thing you need to keep in mind. And then you solve for y prime in terms of x and y. This is what we did. And you already know the equation of the tangent line. The equation of the tangent line is going to appear again when you're asked to find the linear approximation. Remember, the linear approximation is given by the tangent line at a certain point. Okay, so something like this is sure to appear in the exam. Something like differentiate y equals x cos x divided by x plus 1 sine x. And well, they might give you a hint or not about how to do it, but the most efficient way here, if you remember, in that section was to take natural log first and then differentiating. Okay, so logarithmic differentiation was very useful here because the numerator and the denominator are both products. So taking logs makes everything easier. Hint. Alright, so there's two kinds of problems, and there's going to be another problem for sure that involves related rates problem. And for this, I mean, I can only tell you, I mean, just remember the steps. Find the variables, find the relevant variables, and then find the geometric relation. Find the geometric relation here, and differentiate it, differentiated shaded. Finally, use the data. So typically they will ask you to find a rate of change or a velocity given in terms of the velocity, which is known, of another quantity. So you need to find the geometric relation and then differentiate implicitly. Okay. And those are the steps for this kind of problem. Another kind of problem, I don't know yet if there are going to be some multiple choice questions or not, given the nature of things. Well, given how things are changing each day, and then people have not decided, different opinions. But it may be that sometimes I mean that there might be some multiple choice questions, or these kind of questions that usually appear in the multiple choice section are rephrased so as to fit the new format. And one of these questions could be something like f of x. You're given a function that's defined as the composition of two functions, f and g, and you're given information such as f of minus 2 prime is equal to some quantity, say 4. F at minus 2 is equal to 8, say. G at 5 is equal to minus 2. G prime at 5 is equal to 6. So what is f prime at 5? And here you just need to notice that this is a problem about the chain rule. Because in order to find the derivative of f, capital F, at 5, you need to know the derivative f prime at g of 5, and you need to know the g prime at 5. So f prime at 5 is equal to f prime at g of 5 times g prime at 5. And you have to look for in the data they're giving you, like this. For example, the g prime of 5 is just 6. So this is 6. G of 5 is minus 2. And you need to know then the value of f prime at minus 2, which is 4. So this is 4, so this will be equal to 24. Okay, find the linear approximation is another type of question. So find the linear approximation of a certain quantity. Find the linear approximation of a function at a point at a given point. A given point, and you already know that this is the given point at a given point. So, and you already know that you need to find the derivative of the point. You already have the value, the function of the point, and those are the main things you need to have at hand. And for applications, if they ask you to find the approximation for the, say, the cube root of some quantity, then you need to identify also the function there. So you have to realize that f of x is just a cube root of x. And typically what you have is that what's inside the cube root is almost a perfect cube. And you need to identify the point at which you need to linearize. We've gone over examples like that in previous examples. And also L'Hopital's rule. So from the typical examples, things that I would advise you to do is to check the hypothesis. Always check the hypothesis. So check whether the numerator and denominator both go to 0 or to plus or minus infinity. At the same time, they're both diverging or they're both converging to 0. in which case you can apply the rule. Then also when you have expressions, when you're asked to compute which grows faster, then this means that you're asked to compute the limit of f of x, g of x, as x goes to infinity. And then you need to check the hypothesis again. And typically f goes to infinity and g of x goes to infinity as well. So you can apply L'Hopital's rule, and then you will end up computing the limit of f prime over g prime. And if that gives you infinity, that means that f grows faster than g. If that goes to 0, that means g grows faster than f. Some things you need to know is that natural log of x always grows lower than x to any positive power, alpha. So if alpha is greater than 0, x to the alpha is always going to grow faster than natural log of x. In the same way, e to the x always grows faster than any polynomial. Finally, when you're asked to compute, say, a limit like this, like x to the 4x, x approaches 0, plus, always, absolutely always, take natural log. Take the natural log and compute the limit instead of x to 0 plus. Okay? And here, when you have to apply the chain and the L'Hopital's rule, keep the natural log where it is, and write for x as 1 over 4 x. Okay? And once you get this limit, which is 0, then you pick this number here. Well, it happens to be 0 in this case, and the limit you're looking for will be e to that number. This is the limit you're looking for. Okay, that's it for now. And good luck with the exam.